Hello everyone. Now I want to talk about some problems from Unit 7 guided notes. The first problem I want to talk is the question number 31. You are asked to solve exponential equations. So the given equation is 5 to the x squared plus 8 equals 125 to the 2x. To solve, meaning you need to find the value for x, okay? And if you observe the left side and the right side, they have different bases. So the first thing you want to do is to convert into the same base. So we can easily see that 125 is 5 cubed. 5 cubed equals 125, then 2x, okay? Now you have 5 to x squared plus 8 equals 5 to 6x. So you just multiply these two exponents, which is 6x. Now you have the same base. In order to make these two left-right equal, the exponent has to be equal. Okay, now become x squared minus 6x plus 8 equals 0. You move this 6x to the left side, become negative 6x. And to solve this quadratic equation, you have learned before you could use a factor x minus 2 times x minus 4 equals 0, because you find the two factors of 8, which is 2 and 4, which added together make this 6. Negative 2, negative 4 make this negative 6, okay? And now we're going to use property of multiplication. Two numbers multiplied together equals 0, then use the property we have x minus 2 equals 0 or x minus 4 equals 0, either, okay, either this or this, or maybe impossible to be both. So this gives us x equals 2, this gives us x equals 4, so x has two values, okay? So the next question I want to talk about is 36 and 37. So 36a says 5 to a's power equals t. You are asked to rewrite an equation involving a logarithm. Okay, so the base is 5. To write as a logarithm, still base 5, the logarithm t is 8. So I usually trying to connect the exponential and the logarithm by just draw the circle, say 5 to a's power equals t. Okay, let's do one more. It's x to negative 2 equals 12. So always remember, base is still base, 12 is negative 2, like this. X to negative 2 equals 12. X to negative 2 equals 12. So C, it's e to x power equals 10. So we have log e to 10, log e 10 equals x. E to x power equals 10. And also you may remember, when we have base e, we just say ln, this always representing base e, 10 equals x, either way, okay? So this is question number 36. Let's do the next 37. Let's take a look at 37. It's kind of the opposite. You were given the logarithms and you are asked to write equations, exponential equations. As I said, I always draw the circle thing, like 2 to y power equals 12, say 2 to y power equals 12. So b, that's a, b is logger z 12 equals 6. So draw the circle, it's z to 6 power equals 12. So c is logger 2 10 equals a. So draw the circle, I have 2 to a's power equals 10. Okay, some of you still are confused about what's the order, what's the connection between exponential and logarithm. So here are some examples, okay? Okay, so now I want to talk about question number 40b. Let me find it, 40b. 40b is I find the domain of each logarithm function, logarithmic function. 40b, we were given fx equals logger base 2, x plus 3, x plus 1 is the logarithm. So we know that the logarithm has to greater than 0, which shows us x plus 0, or x plus 3, x plus 1 has to be greater than 0. In order to make the whole thing greater than 0, we have two cases, x plus 3 that are greater than 0, x plus 1 greater than 0. When both numerator and denominator greater than 0, the fraction greater than 0, or when both are negative, less than 0, x plus 1, negative, division also make it positive. So we have two different cases. Let's take a look at the first case. The first case, x plus 3 greater than 0 give us x greater than negative 3. This gives us x greater than negative 1. So on the number line, say this is 0, this is negative 1, this is negative 3. So we have greater than negative 3 is this part. Greater than negative 1 is this part. We have to satisfy both conditions, so we find the overlap part, which is x greater than negative 1. So that's the first case. So the second case, you have x less than negative 3 and x less than negative 1. If you draw a number line, 0, negative 1, negative 3. So less than negative 3, less than negative 1. Since we have to satisfy both, you need to find the overlap part, which is x less than negative 3. So combine this case and this case, greater than negative 1, less than negative 3, that will be the domain of the given function. So if you write in a notation, in an interval notation is negative 3 to negative infinity to negative 3 and negative 1 to positive infinity. Negative 1 to positive and negative infinity to negative 3. So that's the answer to 40b. Okay, some of you got only one side, one case, and ignore the other case, but you have to solve both cases and combine them together. Okay, so the next question I want to talk about is question 56. Now is the D. We were asked to simplify e to logger e squared 25. We are asked to simplify this. Okay, the formula we can use is should be a to logger a to m is m. So to use this formula, this base and this base has to be the same. But in this problem, the base here is e, the base here is e squared, they're different. So you need to simplify this part first to make the base e. Okay, so basically you could take a look at the whole thing as a y. Assume we use a new y, log e squared to 25. Okay, so as I mentioned, to write an exponential form, it's e squared to y's power equals 25. And this part can rewrite as e to y's power squared equals 25 is 5 squared. Something squared equals 5 squared, so e to y's power equals 5. Okay? Their power are the same, so to make sure they are equal, the base has to be the same. So e to y's power equals 5, we rewrite as the logarithm become log e to 5 equals y. So y, we solve the y equals log e to 5. So this one become, because I assumed the whole thing as y now is log e to 5, become log e to 5. Say e and e, a and a equals the m, so this equals 5. Maybe you want to think this way. So e squared, here is 5 squared, so you can put the whole square outside, or maybe we say cancel out, become log e to 5. So simplify as log e to 5. E and e now become the same base, so the answer should be 5. Okay? I also want to talk about question number 57, both A and B, okay? 57A. Let me take a look. So 51, 2, 5, 6, 7. Okay. 57 says write each expression as a sum or difference of logarithms. So the A, we were given a logarithm 3, base 3. Then we have x minus 1 times x plus 2 squared. Okay, so the formula we can use is log a to m times n. If they are multiplication, you have log a, you can separate and write as addition. Now we have x minus 1 times this. So here is a multiplication. So you could rewrite as 3x minus 1 base plus log 3 base x plus 2 squared. So you separate them into addition. And the next formula we can use is once we have log a to mb squared, then r squared, you could put this square or this r's power to the front, become r log a to m. The same thing here, the 2 can put in front, become log 3x minus 1 plus 2 log 3x plus 2. Now we are done with the A part, okay? Let's take a look at B part. B says log base 5 x squared y cubed over square root of z. Okay, that's the whole thing. You saw the top multiplication, then the overall is a division. Now you can have this formula to use. M over n equals log am minus log an. Okay, division becomes subtraction. So overall this become log 5 x squared y cubed subtract log 5 square root of z. Okay, now we have multiplication here, so you subtract, convert to addition, squared plus log 5 y cubed. And this square root of z, actually you can write as z to half power, because any square root can rewrite as a 1/2 power, okay? Now we are going to reuse this formula to put in front and 3 put in front and half put in front. So that's the answer. Make sense? And those are all the problems I want to discuss here today, and hopefully my explanations help you to have a better understanding.